Good evening to all of you. We want to welcome you to tonight's webinar from the National Weather Service in Boston. I'm Joe Deli Carpini, the Science and Operations Officer. We're back in 2024 with some new webinars, and tonight we're going to talk about some of the recent storms. We'll go into a few of them in some detail, give you some of the things that we were looking at when we were providing the forecast, and then we'll do an update for the winter outlook, kind of talk about where we are right now and then where we're kind of headed. So go ahead and use the chat box for any questions. I'll try and answer as many as I can at the end. And we are recording this webinar, so it will be on our YouTube channel tomorrow. And you can find all of our past webinars there too. If you want to find out when we're scheduling new webinars, you can join our email list. I send out a BCC email to everybody once we schedule them. Or you can check our webinar page. We'll put a link up at the top in our news of the day when we schedule those. So we'll try and get some more scheduled as we go through the month of February here if we have any good weather events. So stay tuned for that. And of course, stay tuned for our weather briefing after the webinar tonight. So winter so far, we've had a lot of storms, but certainly not a lot of snow. So here's a listing of all the storms that we'll talk about tonight. The ones in red that are highlighted, we'll take a little bit closer look at those. Some interesting angles to those storms, but certainly it's been a pretty active winter so far. The strong El Nino has kind of come in as advertised with a lot of storms coming out of the Gulf of Mexico. So, we expect, will that continue? It's kind of taking a breather right now, but we'll see if that's going to pick up again as we go through February. So the first storm was December 10th and 11th, and this one featured a lot of rain, strong winds, and even some minor coastal flooding. If you remember early in the morning, this is the radar loop on the right, there was kind of a narrow line of showers, a little bit of embedded thunder too, that moved through the region. But rainfall total is pretty healthy, anywhere from about 2 to 5 inches across the region. And you can see highest totals across Connecticut, Northwest Rhode Island, into the southern part of Worcester County. So that's how we started off our stretch of storms. And there was a bit of river flooding too. So one of the things that we look at, and I'll show this in some of the parts of the review tonight, is something called the Multi-Model Ensemble Forecast System. So this is available on the webpage from the Northeast River Forecast Center. And it's essentially takes all the ensembles, so the different models, to show the potential for flooding at various river points. So in this case, we were looking at the potential for several places to reach minor stage, as outlined in orange, or even a moderate flood stage in red. So the ones in yellow were coming near their action stages, which is a little bit below flood, kind of like a heads up. And then green would be no flooding issues at all. But you can see quite a few into that minor and even moderate flood category. So when it came to the coastal flooding, this was a relatively minor event. We were looking mostly focused on the south coast, only about a foot of surge. And this was the forecast from the Stevens Institute ensemble, which we look at. But notice there's a pretty good range here in the gray from as little as just under 5 feet to as much as maybe 7 feet. And that just had to really do with uncertainty and the timing of the highest surge. In this case, it looked like the surge was kind of come in a little bit after high tide by a couple of hours, which would really spare those higher totals from coming in. So as a result, Providence did stay below flood stage in this one. But as we'll show, there certainly was a lot more coastal flooding with a lot of these storms. But just to show you what we use, and we use this quite a bit, kind of showing our best case, which would be the lower range, and then the worst case would be the upper range, just to brief local officials on the flood threat. So the first one we're going to take a closer look at is the one the week before Christmas. This was a pretty significant storm for much of the East Coast. As you can see here on the left, it traveled up from the Gulf of Mexico and right up the East Coast. This is one of those Miller A storms, and I'll talk about that a little bit more when we get into the kind of the expectations for the next few weeks. But you can see there was a lot of heavy rain, and there was a snowpack across northern New England that melted very quickly, especially across Vermont, New Hampshire, and Maine. There was a lot of deadly flash flooding from that, just in areas to our north. A lot of strong wind gusts along the coast, a lot of rough surf. There were high astronomical tides, so there was coastal flooding as well as power outages from the strong winds. And you can see the top image here has the rainfall totals, a couple of corridors, one along the east slopes of the Berkshires, about 4 to 5 inches, and another in Northwest Rhode Island, 5 to almost 6 inches of rain, in some cases over 6 inches in the northwest hills of Rhode Island, and you'll see that what that did to some of the rivers there. But the wind speeds are on the right, lower right here, and you can see there were a couple of areas of really strong winds. Usually, we expect Cape and the islands, and they certainly, came through with some 60-mile-an-hour gusts. But there was a second area right around Metro Boston, including Logan Airport, where the winds really gusted over 60 to almost 70 miles per hour, which is unusual for us to see with a southeast wind, but it just really speaks to the strength that this storm really had as it moved through. So in forecasting the storm, we knew there was potential for what we call a highly anomalous or highly unusual storm several days in advance, and that's where we use our ensemble forecast. So I'll show some of the things that we looked at here. Overall, the forecast and impacts fairly accurate. The rainfall and flooding forecasts were probably the least accurate of all of them, somewhat underdone. Too low on our rainfall in Rhode Island and portions of central and eastern Massachusetts. And as a result, major flooding occurred on the Pawtuxet River, which goes through Cranston and Warwick in Rhode Island. That level of flooding was really not anticipated. The coastal flooding forecasts were really focused on the south coast and a little less so on the east coast, but we saw really more significant coastal flooding on Martha's Vineyard and on parts of the Nantucket Sound side of Cape Cod, which we really were not expected due to southeast winds. So we had a little bit of a lesson there in not underestimating the storm surge in those cases. So looking aloft, this is 500 millibars. This is a loop, and again, this is about 18,000 feet. This is the steering level, and you can see that big trough exiting the Great Lakes as it starts again. And you'll see another trough here in the south. They kind of come together as the storm system lifts over the northeast. And what that does is it really pulls the storm inland rather than kind of nudging it offshore. You can see there's what we call a negative tilt, kind of northwest to southeast, and that draws the storm in. And that gave us a warmer storm since we were on the eastern side of it, as opposed to one that moved off the coast. So there was near record moisture for December. What we look at is something called precipitable water, and that's essentially the amount of water that's in the atmosphere over a given location. So if you kind of wrung out the atmosphere, that's what you would kind of see. And when you get at values over 1 inch, you're starting to get into the more tropical air, especially closing in on 2 inches. So in December, to see values nearly 1.6 inches, that's pretty significant for December. The record for the month is about 1.7, so we were almost in record territory. And the upshot is it really indicates we were dealing with really highly unusual amount of moisture that this storm had to work with. So certainly heavy rain would be a possibility. Now, something else to look at in the ensembles are wind anomalies, and they tell us, how much different than normal are the wind speeds, how much stronger than normal. And if we know that, we know, first of all, the potential for damaging winds. And we also know, how strong the moisture transport is. So on the left, you can see from the GFS ensemble, this gray shading, upwards of 5 to 6 standard deviations above normal, which is very significant. That's a strong signal really for damaging winds, as well as excessive rainfall. So anytime you start climbing over 2 and especially 3, you're looking at a very, very unusual event. Now, when we look at the actual wind forecast, we look at the forecast soundings, and I'm sure many of you have seen these before from some of our event reviews. In this case, the red line on the right and the green line are very close together. So red line is temperature, the green is dew point. So you can see the air is saturated all the way up thousands of feet in the atmosphere. But what we can also do is estimate the amount of mixing, or how high the mixing layer will be. So in this case, the model is showing really not much. It's showing about 24 knots of wind, but that's with a temperature in the 50s. If we warm the temperature into the low 60s to get an idea of what could potentially mix, we use this blue line. Well, it's mixing here to about 1,500 feet. So that's a lot more significant than just down at the surface. And if we go to the right, what are the winds at 1,500 feet? About 57 knots. So that's telling us that there's the potential, if it warms in the low 60s, we could see gusts close to 57 knots or 66 miles per hour. And in fact, Boston did reach 63 degrees, and the peak gust was very close to that, 59 knots or 68 miles per hour. So this works very, very well to kind of get an estimate of what the wind gust could be. Now, if it stayed cooler, if it stayed in the 50s, we would have probably only had winds of about 20 to 30, maybe even 40 miles per hour. So the rise in temperature made really a significant difference in this case. So the other aspect was flooding rain, and overall the flood impacts were well forecast. Again, in Rhode Island, the rainfall forecast was underdone, which ended up being the river forecast was also being too low as a result. But we used the ensembles highlighting the potential flooding 3 to 4 days ahead. And knowing from what we looked at in the ensembles that the system had unusually high moisture, very high, strong dynamics, that helped improve on the model rain forecast a little bit. So here was 3 to 4 days ahead of time. This is the river forecast ensemble, and you can see a lot of points in that minor to moderate flood category. So the storm that came in on December 10th, actually what we call it primed the pump. So it brought up the stream flows leading up to this storm. So it didn't take much for this storm to really get rivers to come out of their banks. And we often see this prior to a lot of our big floods, these back-to-back or even back-to-back-to-back storms. March 2010 is a great example of that. So this was a case where the first storm got the river levels up and the second one brought more rain, and they were all out of their banks. So when we talked about the models, the high resolution models did a very good job, and this is a high resolution ensemble. Had really good depiction of the higher totals east of the Berkshires and also in Northwest Rhode Island. You can see this here. The totals were only 3 to 4 inches, so a little bit underdone, but certainly picked it out right that there was going to be these higher rainfall amounts in the northwest part of Rhode Island. So our final call forecast here, this was on Sunday, the day before. And you can see the areas weren't too terrible. We had the maximum area near the Berkshires, a little bit in eastern Connecticut and northwest Rhode Island, but obviously we could almost double these totals here in northwest Rhode Island as to what was being forecast. But overall, not a bad rainfall forecast, showing lower amounts as you head out toward the Cape and the islands, which is what verified there. But the Rhode Island flooding was fairly extensive and significant. On the Pawtuxet River, Cranston crested at 15.11 feet. You can see here on the left side of the image. And that was the second highest crest on record, just behind March 31st, that should be 2010, of 20.79 feet. So about 5 feet lower than that. Still a lot of significant impacts. You can see River Street here in West Warwick was very deep water around in that area, as well as through Cranston as well. Some of the other rivers in Rhode Island, likewise, the Blackstone River through Woonsocket reached its moderate flood stage. It was at 13.39 feet, and that was the highest since the March 2010 floods. There were a number of businesses impacted, even some school bus parking lots. Schools had to be closed in parts of Rhode Island for a few days until the waters receded. On the right is the Woonasquatucket River. That's at Centerdale, which is in Providence. And that reached its major flood stage. It crested at 8.35 feet. This was the second highest on record behind March of 2010. And the highest level since before that was the October 2005 floods, which were also very significant across Rhode Island and southeast Massachusetts. So as I mentioned, there was also coastal flooding. The real problem really was beach erosion from the pounding surf and the strong winds. On Nantucket, there was minor flooding around the harbor, around Nantucket Harbor, and but beach erosion really hit the south side of the island strong, as you can see there. The tide gauge only went into minor flood, but really a lot of pounding of the surf along the south shore of the island. And Martha's Vineyard was even more impacted. This is in Edgartown, the South Beach area. There was damage to fencing, other structures, including the lifeguard shack here on the top right, and the Woods Hole weather station was also damaged. Atlantic Drive, which runs kind of the length of the beach here in the middle, was impassable. Sections of the road had been undermined and flooded, and a lot of Edgartown Harbor was also flooded with some deep water. So that part of the island really took the brunt of it. There was also flooding in Vineyard Haven, which was a little bit of a surprise to us on a southeast wind, but there was enough surge and enough wind to bring the water right into there. So this is the Five Corners area in Vineyard Haven. Fairly deep water up to the wheels of cars. There were a number of cars that stalled out in the area and had to be towed away. So certainly some deep water from that as well. Going down the coast to New Bedford, another area that was pretty hard hit, a lot of beach erosion, damage to some seawalls, but minor flooding and overwash as far as water levels. But just the pounding of the surf really did a number on a lot of these south coastal communities. And going down to westerly Mesquamacut Beach was really hard hit. That area had been really made vulnerable by some past storms, but there was a lot of significant beach erosion, sand piled up knee deep in some parts of the shore. You can see a vehicle here was flooded. This is kind of after the fact, but you can see a lot of the sand had been moved here on the lower left, but just a lot of damage around Mesquamacut too. Okay, so then we had a little bit of winter, January 6th through 7th, and this was actually what we would call maybe the biggest snowstorm of the season. Not saying much for you folks in the coastal areas and the lower elevations, but certainly was a good storm up across the Worcester Hills into interior northeast Massachusetts, over a foot of snow, and also near the Connecticut River Valley didn't do too bad either, over a foot of snow there. This was a storm that stayed just offshore. Temperatures were marginal along the coast. That's why we didn't see tremendous accumulations there. But once you moved a little bit further inland, that ocean influence was gone, and it was much colder air, especially in the higher elevations, which led to those pretty impressive snowfall totals. Then we move on to January 9th and 10th, just a few days later. All that snow melted, so we had that to add as runoff in addition to the rainfall, which you can see on the lower right. Again, same areas that got hit with the previous storm got hit here, upwards of 4 to 5 inches in parts of Connecticut and Rhode Island again, and even southeast Massachusetts. And this was a storm that tracked to our west, so whenever we have a storm tracking to the Great Lakes, we're on the warm side. We're in more of a southerly or southeast wind, and that just really floods in the milder air to the region. It's hard for us to stay all as snow in those cases. And the other interesting aspect of this storm was there was coastal flooding, again in the locations I just mentioned that were hit hard before, but Boston was really a bit of a surprise. It reached its moderate flood stage of 14 feet with an offshore wind, which is extremely unusual. So we were wondering why was the surge so high? Well, it really had to do with the rapid pressure falls associated with this storm as it tracked up into the Great Lakes. It just raises the level of the water whenever you have great pressure falls. So that seemed to be the culprit there, but certainly a bit unexpected in our case. So going a few days ahead, this was about 5 days before, these ensemble situational awareness tables that we use, and we've shown them in some event reviews. These are good for a first quick glance to see if there's anything really unusual going on in a lot of different weather fields. So we look at things like the upper heights in Z, temperature in T, the east-west wind is U, the north-south component of the wind is V. We look at wind speed, sea level pressure, and these last three are moisture variables. So notice down in the boxed area, we've got many, these fields, especially in wind, pressure, and moisture, that are fairly, high standard deviations, anywhere between about 3 and 4. Or you can look at it from a percentile perspective on the right, over the 90th percentile, which is extreme, or even near the maximum of the model's climatology. So that's telling us right here that there's some sort of potentially extreme event set up for January 10th. And looking at our 500 millibar level again, just to see kind of how things transpired, another cutoff low coming out of the south, tracking west of New England. It went up over the Great Lakes, and again, that pulls the storm back. It doesn't allow it to head out to sea or even come over us. In many cases, it pulls it right back into the eastern Great Lakes. So this, again, is a very warm setup. If we wanted to have more in the way of snow, this closed low would have to be over or just south of New England to really keep the cold air locked in. So just wasn't happening here. And again, we had record moisture for January 10th, values up near 1.3 inches, which was just above the record of 1.25 inches on January 10th for Chatham. And the monthly record is a little higher at 1.6. But again, same as before, indicates highly unusual amount of moisture with this storm coming right out of the Gulf of Mexico and up the East Coast. So looking at this a few days before, this is 3 to 4 days before. Here's the probability of 2 inches of rain or more from our national blend of models, which think of it as just kind of a kitchen sink of every model, every ensemble that's available. So it's showing, a better than 50-50 chance, upwards of 60 to 70% in this green area, of seeing more than 2 inches of rain. And 3 to 4 days ahead, it may not seem like a lot, but that's actually a pretty big signal. If you're seeing very high probabilities 4 days out, it's telling you there's a lot of model agreement on heavy rainfall in this area. Now, as we got a little closer, a couple days out, this was the high-res ensemble. Again, a very good handle on higher totals in parts of Connecticut and Rhode Island. The amounts were a little bit overdone this time near the east slopes of the Berkshires, but Rhode Island was not bad. We see some totals 3 to 4 to 5 inches. and that actually ended up verifying. So again, it's hitting that northern part of Rhode Island, which was already very vulnerable to flooding. So speaking of that, we go to our river forecast ensemble, and it was lit up again. Many areas in orange showing minor flooding, and several in red showing potential moderate flooding. And that's because the stream flows were still high from all of the previous storms that had been very wet several weeks. And plus we had some melting snow this time as well. So, definitely priming the pump again to get into another significant flood. So here's the forecast that went out just before the Tuesday before. So again, showing, same areas, again, with the higher amounts, but again, too low. Again, you could almost double these totals in some areas, especially in Rhode Island, but overall the axis was correct. So river responses this time, not quite as high, but up there, again, reaching over 14 feet into major at Cranston, and at Hope Valley, which is in the western part of the state, crest over 9 feet, which is in its major flood state. And this was the third highest on record. Again, the record was March of 2010, and behind that was June 6 of 1982, which was another significant flood event in Rhode Island. Once again, as I mentioned, a lot of coastal flooding and erosion, same areas that were hit: Nantucket, Edgartown, Vineyard Haven, and Mesquamaket again. A lot of cleanup to be done, and a lot more damage to dunes and beaches that were already especially vulnerable from the previous storm. Then on to January 13th, this was another flood event, not as severe as the other ones. You can see the rainfall totals were a little bit less, but unfortunately focused on the same areas, 1 to 3 inches in Rhode Island. There was another round of substantial coastal flooding and beach erosion, though. Same kind of system as the last one, entering into the eastern Great Lakes, putting us in a very warm, mild southeast flow. So not as much rain, but it did produce some river flooding. Really, the issues this time were the coastal flooding and the beach erosion. And then January 16th, we were around Martin Luther King Day, and this was a minor snow event. This was a low that kind of hugged the coastline. Many areas started off with snow. Some of the coastal areas did switch over to rain, but overall, a light snowfall of about 2 to 4 inches for most places, including many areas that hadn't seen much snow at all up to that point. But certainly some higher totals up to the north of our region, but a little bit of snow and even some ice, which is certainly typical in these strong El Nino winters. You don't see a lot of snow. You see more in the way of a wintry mix over to rain or just plain rain. And then finally, our event this past week was January 28th to 29th. We'll take a little bit closer look at this one because there's some interesting things to kind of uncover. If I took this map on the left and just said, hey, with this storm track, is this a good snowstorm? You probably would say yes. And, I'd probably agree with you. This would be a good one for Boston and Providence and even down into Hartford. But we were just lacking the cold air ahead of it to really give us some big snows. And you can see really not much of anything in the coastal areas, the South Coast, virtually nothing, an inch or so in Boston, and even up into the Hartford area, not that much. Really was focused again in the higher elevations where totals were generally between about 4 and 8 inches at most. Again, a little bit higher as you cross the border over into New Hampshire. So we'll take a look at this one and, what's the difference with this with the others? Well, at 500 millibars, I'll do this loop a couple of times. Notice how you have a deep trough in the south. It lifts up, closes off, and then kind of weakens as it lifts up into New England. That's called a trough that de-amplifies. It opens up and weakens. So there's really not a lot of strong upper dynamics to really support a strong low pressure system at the surface. There was one, it wasn't too deep, but just didn't really have the upper support to really strengthen. So for these big snows, as it says here, you want to see this upper low close off, not open up as it reaches our area. So you'd want the low to kind of close off just to our south. That's really our best scenario for big snows. And this certainly didn't really match that scenario at all. So temperatures were also pretty marginal for snow accumulation. If you woke up Sunday morning, there was a little bit of snow, even in some of the coastal areas. Temperatures in the higher elevations, they were at or below freezing for the duration of the event. So no issues there at all. That was kind of a slam dunk for the accumulations. But it was the lower elevations, the coastal areas that really were the difficult part of the forecast. Temperatures for the most part were above 33, 34 degrees, which made it difficult for the snow to accumulate. And as I'll show, there was deep moisture and lift in what we call the snow growth zone. And that's, you want to have the lift focused in roughly between about -12 and -18 Celsius. That's what gives you those big, huge snowflakes that really accumulate. So we just didn't really have that for too long. It did snow, but the warmth of the surface really prevented much in the way from accumulating. So here's an image of what I call a snow growth. So what you're looking at in the contours, that's the depth of that snow growth zone. How deep of an area is it covering? It's kind of in meters. So the higher the number, the better or deeper the snow growth area is. And in the green is where we have high humidity within that zone. So we want to have a combination of high humidity and also a very deep snow growth zone. And we didn't have that really. 10 in the morning, it was snowing in much of the area. Maybe you got coastal areas a quick dusting, but it was somewhat deep, about 800 meters, and it was saturated. So this area of saturation was moving through about early afternoon. But to our south at 10 o'clock, there was this, what we call a dry slot. There was drier air. We don't have those greens in this area. So as this advanced northward, it reached our area by 1, 2 o'clock. That really shut off the deep moisture, shut off the snow, and left us with kind of lingering light rain, light drizzle if it was warm enough, even some light freezing drizzle where temperatures were closer to 32. But it was kind of game over at that point. The better moisture was located kind of to our west and north at that point, which is where at least some more of the snows had fallen in that area. So another reason why we didn't see a lot of snow was because of the amount of lift and temperatures kind of staying above freezing. So these are looking at forecast soundings for Hartford. On the left is 7 in the morning, and the sounding shows rain. And there's a couple of reasons for that. So let me point out a few things. Again, red is temperature, green is dew point. The closer they are, the more moisture you have or higher relative humidity. We want to watch this 0 line right here on the left. So anything to the right is above freezing, anything to the left is below. And you'll notice a little bit, right off the ground, we're above freezing. It does cool off a little bit, but then there's another warm layer just below 1,000 feet. So that's telling us that as the snowflakes come down, they're going to melt. They're going to try to refreeze, but it's not really cold enough to do that. So in this point, this is really a rain sounding. And the white line here shows us the amount of lift next to this white line. So when there's more space, there's stronger lift. This is kind of weaker lift. So you don't really have a lot of lift either to generate a lot of rain or snow. Now on the opposite side at 11 o'clock, remember we had that good snow growth zone move in. The entire sounding is just below freezing. It's saturated, and we have much stronger lift over the area. So what that does, it does something called dynamic cooling. And when you have very strong lift, it actually makes the atmosphere colder through a number of these different processes. So what that does is it forced the temperature colder because of the strong lift, changed it over to a brief period of snow. So that's why many of us from the later in the morning to early afternoon also saw a good period of snowfall. And then once this lift exited, it warmed up again and went back to that light rain or drizzle. So between the snow growth zone and between the strong lift moving through, that's what gave us our burst of snow with this latest storm. So the final call issued on Saturday, not too bad, showed, an inch or so for much of the area, really focused on the 4 to 8 inch totals in the higher elevations, northern Worcester County, east slopes of the Berkshires. And in this case, the forecast really didn't change too much from the initial ones that had started being issued by Thursday, really just showing low amounts near the coast because of the temperature difference. And, just a reminder, a lot of the models do show you snow accumulation. Those are straight 10-to-1 ratios, so they're not always going to be good. If it's below freezing, they'll probably be reasonable. And for the higher terrain, they did very well. But when you're in these marginal temperature situations, 33, 34, 35 degrees, look at the model snow depth change, which is available on most of the models. That will give you much better results for these lower elevation coastal areas where temperatures are more marginal. And this certainly really worked out well in this case. All right, so that's a look at those storms for part 1 of our presentation. Now we're going to move on to our update for kind of where we are and then where we're headed for the month of February. So this was from that January storm. This was probably the best snow picture we've gotten at the office all winter. And yeah, there was snow on the ground at that point. Okay, so we're going to use our 4 climate sites, Boston, Providence, Hartford, and Worcester, which are our long-term sites. And these statistics are through January 31st. So keep in mind, they include 2/3 of the winter. We still have 29 days to go for meteorological winter. But right now, temperatures, no surprise, are above normal. Boston is at its 5th warmest, Providence its 4th warmest winter. But notice inland, it's the warmest winter right now at both Hartford and Worcester. So obviously, I think these temperatures will change as we go through February, whether they go up or go down. But we're probably looking at overall a top 5 warmest winter across southern New England, aside from if we get a really good cold outbreak, which is still in the cards. But as of now, we're in the top 5 warmest winters for our climate sites. How about precipitation? Probably no surprise either. It's been wet. You can see Hartford, 2nd wettest, Providence, 5th wettest, Worcester, 6th wettest. Boston, not quite, 22nd, so a little bit less there. There's certainly the rain, as I showed you on a lot of those maps, was focused kind of through that Hartford, Worcester, Providence corridor. They've done very well. So that's where it's, within essentially a top 5 wettest winter. Outside of that, it's been a little bit drier, but still above normal. The curve, the brown line on the curve represents the normal precipitation from December 1st to the end of January, and the green curve represents the observed precipitation. So the more distance you have between these two, the greater the departure from normal is. What you can certainly see, pretty close, but a little bit more so for Providence, Hartford, and Worcester. Snowfall, probably not much of a surprise either. Well below normal, and this is again through the end of January. Notice Boston, it's its 5th lowest snowfall total for the winter. The others are, a little bit better. Providence is 11th lowest, Hartford 17th, and Worcester 28th. It's certainly been a little bit snowier across the interior. And again, you can see that below the normal curve here, the brown line, a little bit less room, especially in Worcester, as opposed to Providence and Boston. So the coastal area is definitely well below normal. The interior, especially the high terrain, has actually done pretty well. That's a little bit closer to normal there for those locations. So when we're talking about the winter pattern, it's all about El Nino, which I'm sure you know. Just as a reminder, that's the sea surface temperature anomaly or difference off the Pacific coast of South America. And when it's above average, that's El Nino. That's what we're in now. When it's below average, that's La Nina. That's where we were last year. But there is an ocean-atmosphere connection that results in global weather influences. And right now, the El Nino is forecast to continue into the spring, although it will gradually weaken. So in New England, there really is no direct correlation, but during these stronger El Ninos, it tends to favor below-average snow and milder winters, and we're certainly seeing that. So for us, El Nino kind of provides the background for the winter, but it's not the complete answer. There's a lot of other factors in mind that we'll talk about. But also keep in mind, we're dealing with a changing climate, and we have warming temperatures over the past 20, 30 plus years. We also know there's a greater frequency of heavy precipitation, meaning the 1 inch per more rain or melted snow. And the other thing is just the law of averages. Many of you who like the snow will remember we saw a lot of big winter storms, blizzards during the 2000s, the 2010s especially. So, maybe this is also just a little bit of Mother Nature doing the balancing act, where the law of averages says you have to have a few, below average winters after so many near or above average winters during those 2 decades. So, but really, I'll talk about it in a minute, but our weather patterns are much more transitory, meaning they change. They're not driven by so many global influences to a large degree. But as you may know, El Nino is forecast to weaken and eventually end sometime in the spring. We're looking in this box here, this December, January, and February. Notice it peaked in December, and it's on its decline, except for maybe 1 or 2 models showing it strengthening again. But it's the overall consensus is this will gradually and steadily weaken and become neutral maybe sometime around May, June, July in the later part of the spring or early summer. And on the right is the climate forecast system. Think of this as kind of the really, really long-term GFS forecast. And it's showing a similar trend, a peak that occurred in December and January. Now in February, we're seeing a steady decline, and it's just a matter of how quickly it erodes. But kind of the consensus is here sometime March, April, May, or maybe more like the May timeframe. And possibly even reaching another La Nina as we get into the latter part of the summer and the fall. So we'll kind of keep an eye on that as far as next winter's trends. But certainly the weakening of El Nino has begun. On the left, these are weekly temperature anomalies. And notice it's still above normal, but the amount of reds near that zone are kind of decreasing a little bit. You can certainly see that by last week's. And here's the change overall. You can see there's definitely been some cooling in the central and eastern Pacific. Still a little bit of warming going on just to the west of the 180 degrees longitude, the date line. But overall, the trend is definitely for cooling in the eastern Pacific. So we do know, as I mentioned, strong El Nino does favor more coastal storms. And tell me if you've seen this before this winter. A more active southern jet stream favors what we call these Miller type A nor'easters. These are the ones that come out of the Gulf. They are loaded with moisture, and they either deposit heavy rain or heavy snow in our area. This year, it's been a lot of heavy rain. But if we do have the cold air in place, they can produce our higher end winter storms. For those of you who like to look back at the big storms, I always say the President's Day storm of February 1983, the Megalopolitan storm, that was a big one. That occurred during a strong El Nino. So it's just a matter of, do we have cold air in place? But these are definitely the ones that that give us the big snows potentially. So, it's Mother Nature's kind of taking a breather now, but we'll take a look at the weather pattern here in a few minutes and kind of see where we're going. For those who may not know too, the Miller type Bs are the ones that come across the Great Lakes, and we have the reforming over the Carolinas, that secondary low. That's a Miller type B. Those are still significant winter storms, but the Miller type A's are the real big ones that can really deliver for you snow lovers. So just a reminder, as I talked about, El Nino is a good, background kind of predictor as to what's going to happen, but it really comes down to our jet stream patterns, which can change kind of over a period of weeks. They're not very persistent. So when we're in what's called the positive PNA, Pacific North American Oscillation, and an oscillation means just that, it changes. So when we're in the positive phase, we have a ridge over the western U.S., and a trough over the east. And it's these troughs that give us the colder air and usually the storm track up the coast. So this is when we have a storm forming in the Gulf. It can head right up. If things are, kind of in a good position with the jet stream, which we usually don't know until the storm is actually forming. But this is really the phase we want to see to get our colder and more active weather. On the flip side is the negative phase, where you have the trough here in the west and the ridge here in the east. And this was largely the dominant pattern for last winter. Remember, it was fairly mild, fairly dry as well. We had this big ridge or bump over the southeast for much of the winter. And that's what really, kind of gives us that warm and dry. We haven't seen too much of this year, but I'll show you on our forecast. The ridge is making its appearance a little bit, and that might kind of shut down the southern stream for at least a couple of weeks. So talking about the next couple of weeks, here's where we are. I'm going to use the GFS, and I'll show an animation here in a minute, but just to kind of show where it's going in the next couple of weeks. This is a forecast out for Saturday, February 17th. So just after Valentine's Day in a couple of weeks. What are the long-range models showing? Well, they're showing the northern stream or the northern branch of the jet stream is going to become our more dominant weather feature. So what does that mean for us? It typically means it's a little bit drier. Weaker weather systems coming down out of Canada. Those Alberta Clippers are among those that maybe bring us a little bit of light snow and usually kind of a reinforcement of some cold air. But this pattern overall looks to kind of favor near average temperatures, maybe even slightly above from time to time. Keep in mind, though, average temperatures now in February, we're getting into the upper 30s and lower 40s now. For averages and lows and kind of in the 20s and even 30s for the most part. But those averages will start to climb now. We're getting out of the coldest part of the year, which is usually the end of January. This also shows really no Arctic outbreaks are very likely. Notice up here at the top, that's our polar vortex, and it's kind of sitting way, way north up over Greenland. And again, there's no blocking over Greenland to help really reinforce that cold air. So weather systems that come through in the northern stream are going to exit right out over the North Atlantic. Really nothing blocking or preventing them from making that escape. So really not a source of Arctic air, but it will be colder because notice the airflow comes out of the northwest part of Canada. So it is colder up there for the time being, but really nothing overly cold and stormy. So we talked about the southern stream. Well, it's going to settle down a little bit, but we notice you've got another low coming in off the Pacific. These are going to mostly go west to east, and that's because here's our ridge of high pressure that I talked about before that was over here last winter. And notice it's down across much of the Caribbean and then the Leeward Islands. So that's going to kind of prevent things from really coming up here between the northern stream, dropping its energy down in this ridge, it's going to be squeezed kind of in between the two. So really, it looks like we'll be getting a little bit drier. We won't be getting these systems coming into the Gulf, coming right up the East Coast, at least I would say for the next couple of weeks. So I'm going to put this in an animation. Hopefully this works for you at home, just to kind of show the whole evolution of everything, and it'll end on the last slide that I showed. But again, let's start down in the south. So we see these troughs coming across. This is our southern stream. Notice they're kind of going west to east or even weakening. You've got a ridge of high pressure in the pink that's showing across much of Cuba into even into the Bahamas. So let's watch it again. Notice these lows are more going west to east or even weakening as they run up into this ridge. So there's not much for them to come up the coast and bring us more rain or snow at this point. So again, this was why we're favoring drier weather. And notice to the north, we've got a big ridge of high pressure. You may have noticed well above normal temperatures in the upper and Midwest in Canada. North Dakota was in the 50s today, I believe, or the past couple of days. But notice as we change here, this ridge will gradually break down, and really no source of the polar vortex coming down. It's up there. It's kind of a piece comes down here around Valentine's Day. There's a little brief cold shot, maybe another one, on its heels. But these are very transitory, meaning they're in and they're out. So, at worst, you may have a couple of days of below average temperatures, but not, substantially low. Certainly no Arctic outbreaks. And again, just watch that polar vortex as we go. There's a piece of it off the North Atlantic off the screen. Another piece comes in over here, but really not making much inroads down across the lower 48 at all. It's just kind of reestablishing itself well across Greenland. So again, drier weather pattern looks like it's in the cards the next 2 weeks. Temperatures near normal, maybe even slightly above from time to time. Does look like a quick shot of some cold centered sometime around Valentine's Day, maybe the 15th, or even a day or two after that. But that's really about it for the next couple of weeks. So overall, looks like we're quieting down our weather pattern that's been so active so recently. So our longer range outlooks kind of look like this. Again, high chances of above normal temperatures. This goes through February 7th through 11th across the eastern, essentially 2/3 of the country. This doesn't tell us how much above, but just a high odds of above. So, 40s would fit into this realm. It doesn't mean 60s and 70s. But notice also a bit of a drier signal for us too. Certainly above average in the desert southwest, maybe with some of those northern stream systems entering the upper Midwest, but the eastern seaboard looks to have below average precipitation. Going into the middle of February, again, not much of a change, kind of high odds of above average temperatures from the Great Lakes into New England, even down into the Gulf Coast, below average out in the west, which is probably where we'll see a little bit more of these southern stream troughs emerge, along with a little bit of a wetter signal. Maybe somewhat of a wetter signal approaching us, but nothing really, no high odds there. Or of anything really in the east. So the pattern might be starting to take a change around the middle of the month like we showed, but up until then kind of looks like a quiet stretch. And then going into the latter part of February, odds are showing below average temperatures in the Gulf, along with above average precipitation along the southern tier of states. That tells us maybe the pattern's going to start reloading again at that point with some of these Gulf southern stream systems. Keeping a little bit cool and unsettled along the Gulf Coast. Not bad odds here for below average precipitation. So perhaps the storm track stays a little bit off the southeast coast and doesn't so much bend up here in New England. Notice the equal chances on temperatures. So that's probably also saying the northern streams of that jet's going to remain a little more dominant into the latter part of the month. So we could see some cold spells at that point too. We'll just have to see how things pan out. So overall, again, just in summary, winter has been warmer and wetter than normal, below normal snowfall. Again, not much of a surprise, I'm sure. Our pattern has certainly been dominated by the strong El Nino. That active southern jet stream in December and January produced many East Coast storms with a lot of moisture, strong winds as well. But remember, if the cold air is in place, the pattern does favor big snowstorms. So I wouldn't completely write off that winter is done. We still have our chances going here into February. And speaking of which, climatologically in the year, it's late January and February. Those are our main snow months. So we've got the month to go. The first couple of weeks don't look great, but maybe after that or even into early March, we could see some snow if we can get the cold air to come in. But in the meantime, drier and quieter for the first part of the month. near, maybe even slightly above normal temperatures. And then, the question is, do we turn colder, maybe stormy again later in February? We'll just kind of have to wait and see how that evolves. But right now, looks like we're taking a bit of a break here from all the active weather over the next couple of weeks. So with that, that's a look at winter so far and some of our recent storms. So I will pause here and I will go ahead and answer some questions. I'm sure there's quite a few in the chat. So let's see what we can come across here. Let's see. From Michael, so given the under forecast for Connecticut and Rhode Island, what are you doing to improve those in the future? Well, great question. So we certainly have some cases here. That enhancement occurred with southeast flow, which we don't see a lot of. So now knowing that going forward, we can certainly increase the amount of rainfall in those areas against the higher terrain, east slopes of the Berkshires, parts of Connecticut, and especially northwest Rhode Island into the Worcester Hills. So having that knowledge of what's happened, knowing that the high resolution model that I showed did a pretty good job. Our suggestion from the reviews we've done is let's lean a little bit more on those higher resolution models as we get within a day or two and go with those totals because they will verify. So great question, Michael. And that's another important thing. The reviews that I showed you were just parts of much more in-depth reviews that we did at work, shared with the staff, and with the expectation that we'll do a lot better next time, including the coastal flooding. And so this really gave us an opportunity to see some unusual events that we don't see very much. I can tell you, being here nearly 30 years, I haven't seen a stretch of storms like this in my career. It's been just amazing. So now we have that knowledge base to go off of in the future. Thank you, Michael. Great question. Any thoughts from George as to what have contributed to the under forecast snow amounts in the Rhode Island area for the December storms? Wasn't the December snows there wasn't too much snow in December. It was more January. The rainfall, what contributed, it was just the southeast wind up against the hills that gives us added lift and really wrings out the moisture. So again, those higher resolution models are able to capture that. The larger, coarser models like the GFS and the European model have struggle a little bit with that. So that's one of the reasons right there. From Tom, the strong El Nino of 83 in 2016 coincided with one mega snowstorm on the East Coast, but not one this winter. No, not every El Nino is the same, Tom. It just is a matter of, do you have the storm? Do you have the cold air? We would have had some decent snows this past weekend if the cold air was really in place. We just didn't have it. So it just all comes down to the timing as whether or not we see big snows or not. Question from John, have any of the long-range models performed better than the others this winter? Overall, they've been pretty consistent with one another, and that would include the GFS, the European, and the Canadian. Just anecdotally from what we've seen, the GFS hasn't done too terrible. The European model was a little too strong with this past weekend storm. It had widespread accumulating snows that just didn't happen. It strengthened the low a little bit too much. So, it's a great model, but in this case, it wasn't the winner, quote unquote. But really overall, they've handled this pretty well. Reasonable. The GFS has had its storms that it hasn't done as well on, similar with the Canadian and the European, but overall, they've done reasonably well and have given us, enough confidence to forecast these, unusual events with a lot of lead time. Let's see, from Robert, are the situational awareness tables publicly available? Yes, they are. And I can throw it in the chat in about a second. I'll just have to go in and reach it. But you can look up Ensemble situational awareness tables too, and that you should be able to find that. Let's see. Question from John. Did the January 6th snowfall in the Connecticut River Valley accumulate due to a duration of snowfall or due to storm track or a combination of both? It was really, we had enough cold air in place. It was the storm track. It hugged the coast. So and it really wasn't strong enough to erode the cold air. So kind of kept a light northeasterly flow in the Connecticut Valley that kept it cool, and that allowed the snow to accumulate. So there you go. From Robert, how common are the polar vortexes, we'll call it vortices, during the El Nino years? There was one outbreak for the central part of the country. It's common every year. So the thing I tell everybody is this, it was really hyped by the media a few years ago, but the polar vortex is always there. There's always somewhere around the poles, there's a number of these what are called semi-permanent low pressure systems. That's the polar vortex. So it's there in January, it's there in July. But certainly we see the influences of it in the winter. Now, at any time, there could be a cold outbreak in Europe or Asia or the United States at the same time. That can all be pieces or part of the polar vortex coming down to lower latitudes. So they're always there. It's just dependent on how the jet stream kind of forms and what the pattern is to say, do we get hit or not? Certainly, you're right. The central part of the country got hit, earlier, last month with some really true Arctic air, and we got kind of the edges of it as it was retreating. But it's something that's always there. It's something every winter. It just is a matter of, do we see some of it come down to the lower 48 or not? From John, would a transition to a La Nina indicate a drier summer? Potentially. There's kind of even less of a correlation with La Nina, especially during the summer months. There's usually better correlation during the colder months. But again, I go to the law of averages. We've been so wet. We'll see how the rest of the winter goes, but I would expect we would see some sort of drier period at some point in the spring or maybe the summer. So remains to be seen, but we're in a good standpoint as far as water supply and groundwater and all of that. From Tom, I've never seen an omega block in winter in Canada. Is this important to climate? It's part of changing weather. So let me, actually, I can double back. We can see that. Hang on 1 second. So if we go back, if I can come back on the slide, I'll show you what the omega block is. So that would be when you have, here, we'll do the animation. You've got, it's the Greek letter omega, essentially. So you've got the big ridge, and I'll let this go through again. Trough in the west, big ridge in the middle. There it is right there, the Greek letter omega. That's what it is. So is that important to climate? Well, it just drives kind of the day-to-day weather, if nothing else. So it really is not an important climate signal. It's more of a day-to-day weather thing, if anything. And it'll last a little while. It's what's called a stable kind of pattern. So that's why there's been the warmth in the mid part of the country for a few days. But eventually it does break down, and the weather pattern kind of changes from that. So great questions. All right. So with that, we will stop right there for the time being.